Hi friends, welcome to Mathematics and Statistics, Mastering with PYK. We'll continue with matrices. In this series, we'll be completing multiplication and exercise 2.4. Let's start with concepts. Multiplication of a matrices. Now, when is multiplication defined or when it is possible? So, multiplication of two matrices is possible only if a column of a matrix A is equal to the rows of matrix B. This means we'll first identify the order of two matrices and then we will be able to know whether the multiplication is possible or not. So here in this example, you have matrix A and matrix B. It says add. So for adding a matrix, what do we see? We see the order of the matrix. If it is same, the addition is possible. But here, since the order is same, multiplication is not possible as the column of the matrix A is not equal to the row of matrix B. So here multiplication is not defined. Here in this example where we have a matrix of the order 3 by 2 and the matrix B is of order 2 by 3, the matrix multiplication or a dot product is possible as the column of the matrix A is equal to the row of matrix B, right? And the resultant obtained, say C, will be of order 3 cross 3. So let's understand with the first question. Transpose of a matrix. Transpose of a matrix is denoted by A with the superscript T, A, T, and it is obtained by interchanging rows and columns. Right? So let's get few clarity on the concepts. Transpose of a matrix and its transpose again leads us to the original matrix. Dot product of a two matrix and then the transpose is same as the individual transpose multiplied or the dot product of the individual matrices. Addition of a matrix and then the transpose is same as individual transpose matrices added together. Identity matrix or a unit matrix transpose remains the same, so it is an identity matrix itself. Null matrix transpose is same as null matrix. Here we will be understanding two more concepts, is the skew matrix and the symmetric matrix. If the transpose of the matrix is same as the original matrix, it is called as a symmetric matrix. And if the transpose of the matrix is the negative of the original matrix, it is called as a skew symmetric matrix. So here it's very simple. The first solution, interchanging the columns and rows, we get the A transpose. This means the first row becomes the first column, right? And the second row becomes the second column. In question number 2, again, the matrix is of order 2 rows and 3 columns. So when we do the transpose, it will become 3 cross 2. This means we will have 3 rows getting converted to, the first row getting converted into the first column, the second row getting converted to the second column, right? So here we have the rows interchanging to column and the column interchanging to rows. So the 2 by 3 matrix changes to 3 by 2. Here we have been given an equation Aij as 2 multiplied by I minus j, and A is a matrix which is given of an order 3 cross 3. We have to find three things here. The matrix A, that is the original matrix with given the equation, A transpose, and whether it is a symmetric or a skew symmetric matrix. So transpose is when interchanging rows and columns, and we learned in the previous slide that if the transpose of a matrix is same as the original matrix, it becomes the symmetric, and if it is a negative, then it is called as a skew symmetric matrix. So here we have Aij given as order 3 cross 3. So number of elements would be 3 cross 3, which is 9. So we have to identify the 9 elements of the matrix Aij, right? So we'll have 9 elements in this matrix given A identified by 2I less j. So putting the values, we get the matrix as A 0 minus 2 4 minus 4, then 2 0 minus 2 4 2 0. Now we should take the transpose of the matrix. This means the first row becoming the first column, second row becoming the second column, and the third row becoming the third column, right? So if we see or compare, right, so the first element is 0, so it doesn't matter. Minus 2 is becoming 2, minus 4 is becoming 4. This means A is nothing but minus 80. So here the given condition, the matrix obtained is a skew symmetric matrix. So let's go to the next question, question number 9. We have been given two matrices A and B, and we have to prove that A plus B transpose and the resultant transpose is equal to A transpose plus B, right? So we learned that a transpose of a matrix denoted by AT is obtained by interchanging the rows and columns. Also, we learned that transpose of a matrix and its transpose gives us the original matrices, right? And the transpose of a dot product is same as the transpose of the individual dot product. Similarly, we have addition of a two matrices, the resultant transpose, the answer would be the transpose of an individual matrix added together. We also know that transpose of a unitary matrix or a null matrix is the original matrix. We need to know the two parameters or the two equations. One is if A transpose is A, that is there is no change in the original matrices, then it is called as a symmetric matrix. And if A transpose is a negative of the original matrices, then it is called as a skew matrix. Here, this question you would do it yourself, but let's try theoretically that how it would be equal. So based on this, we have the transpose of the individual matrix, right? So A transpose plus B transpose transpose. So when it is A transpose, we will have to add A transpose, and transpose of a matrix and its own transpose gives us the original matrix, right? So this is what we have to prove by solving, that is finding the resultant matrices. This means we'll be going with LHS, solving it, and then the RHS, and they both have to be equal, right? So before or in the question paper, if you know that the resultant should be equal, this will be a way you can check your answer that the left hand side should be equal to right hand side. Now here we have an interesting problem and a very important problem which you should not miss. It says that you have been given two matrices, say this is A and this is B. We have to find or express a matrix A as a sum of a symmetric and a skew matrix, right? So we know that if the resultant matrix is same as the A transpose, then it is known as symmetric matrix, and if A transpose is a negative of the original matrix, it is called as a skew matrix. we need to find a matrix A, which is the sum of the symmetric and the skew matrix. So say let A be the sum of P plus Q. So how do we find P? P will be given as half of A plus A dash. Here A dash is A transpose and Q is half of A minus A dash. Right? So in this case, if we have to find a symmetric and non-symmetric matrix, we need A transpose and a negative of A transpose. Right? So if we open the brackets, what we will be getting? We'll be getting half of A, right? And this A transpose and this A transpose will get cancelled. We'll be left with one more half of A, that is the original matrix. So the resultant matrix would be the A, right? So this is how we are going to find out. So let's start. The first question, we have A given as 4 minus 2, 3 minus 5. So AT would be 4 minus 2, 3 minus 5. Now we'll find P first. P, we have said that it is half of A plus A dash, right? So A and A dash, 4 plus 4 minus 2 plus 3, 3 minus 2 and minus 5 plus minus 5. So on solving, we get P as 4, half, half and minus 5, right? Similarly, we'll find out for the Q. Q is given as A, that is the original matrix, less the transpose matrix, and the resultant should be half. So we got P, we got Q. So P plus Q, if we say, is A, right? So we come to the original matrix. So the answer is P plus Q would give the symmetric and a skew matrix by which we will be getting A. The second part, right? We know that AT, that is transpose of a matrix, if it is equal to the original matrix, it is called as a symmetric matrix. If transpose is negative of A, that is the original matrix, it is called as a skew matrix. And how do we calculate the sum? When expressed as a sum of symmetric and non-symmetric, we put it as P and Q. P will be addition of A plus A transpose and Q would be half of A less A transpose, right? So transpose is easy. We'll find P by adding A and A dash, right? And we'll find similarly A less A dash, that is Q, right? So Q is this. So when we add P and Q, so this was our P and this is our Q. When we add P and Q, we will be getting A in the form of summation of symmetric and a skew matrix. So this is our answer, right? So try solving these sums so that you get more clarity and a hands-on to this. So see you in the next part. Keep practicing. Bye-bye. Excuses make today easier, but tomorrow harder. So keep practicing. Bye-bye.